Hello friends, today we are going to do converse of Thales theorem. We have done Thales theorem in previous classes, so today we are going to do the converse of basic proportionality theorem. We can call Thales theorem or basic proportionality theorem. So we have already proved the Thales theorem, so today we are going to do the converse of Thales theorem and we will prove it today. So what is converse of Thales theorem? So the theorem is, if a line divides any two sides of a triangle in the same ratio, then the line must be parallel to the third side. So here we have to, let's prove it. So here we have to draw a triangle according to question. A triangle is there. You can name it as A, B, C. Now let's understand the theorem. If a line divides any two sides of a triangle in the same ratio, for example, a line divides it, any line, be it any line. So this is a line. This is a line and it divides. Suppose it is dividing, this line is dividing two sides, one AB, another is AC. Two sides of a triangle in the same ratio. In the same ratio means, suppose this line intersect side AB at this point, you can name it as D. Similarly, this line intersect the side AC at point E. So according to our theorem, what it says, if this line divides these two sides of a triangle in the same ratio means the ratio AD by DB is equal to AE by EC. It is already given in our theorem. So if any line divides the two sides in the same ratio, like AD by DB is equal to AE by EC, then the line must be parallel to the third side. That means this line DE should be parallel to the third side. What is third side here? BC. So we have to prove here DE is parallel to BC. Okay, first of all, given. Now in a triangle ABC, a line is dividing these two sides AB and AC in the same ratio. In the same ratio means the ratio of AD, DB, AE and EC are same. So how you can write it? Given the ratio AD by DB is equal to what? AE by EC. This is given. You can mark it as equation 1. This is equation 1. Now, what you have to prove here? You have to prove what you have to prove. If this line segment divides these two sides in the same ratio, then you have to prove that this line is definitely parallel to the third side. That means DE is parallel to BC. You have to prove DE is parallel to BC. Now you have to make one small constructions here. As you know, D is any line is not parallel to the third side. So let's draw imaginary parallel lines of BC on BC. So from D you can draw any parallel lines and you can name it at E dash. Now we have to imagine, this is imaginary parallel lines. Now you have to imagine that DE dash is parallel to BC. So in constructions you have to write constructions DE dash parallel to BC is drawn. Now DE dash parallel to BC is drawn. Now from basic proportionality theorem, from Thales theorem, in the previous class we have done Thales theorem. So if suppose for example DE dash is parallel to BC, then what we can say? If DE dash is parallel to BC according to Thales theorem, according to basic proportionality theorem, then what you can say? That a parallel, if these two are parallel, a parallel line which intersect the two sides divides it into the same ratio. So what you can write is, just see this triangle A, dash is parallel to BC. DE dash is parallel to BC. So meaning it's, therefore what you can write in this triangle, AD by DB is equal to AE dash by AE dash by E dash C. So what we have done this in Thales theorem. This is Thales theorem. So by basic proportionality theorem. By basic proportionality theorem, we have done yesterday. Any line drawn parallel to the third side divides the other two sides in the same ratio. That is already we have proved. So here we have imaginary line DE parallel to BC. That means this, if this line is parallel to the third side, that means this DE divides these two sides in the same ratio. AD by DB is equal to AE dash by E dash C. So mark it as equal, and the reason is by basic proportionality theorem. Those who have done Thales theorem. So this is equation 2. Now comparing equation 1 and 2. In equation 1, left hand side is AD by DB. In equation 2, left hand side is AD by DB. So in equation 1 and 2, when you compare it, both the left hand sides are equal. So in any equation, if left hand side are equal, then definitely right hand side are equal. So from 1 and 2, from equation 1 and equation 2, their left hand side are equal, that means their right hand side are also equal. AE by EC equals to AE dash by E dash C. Now we just have to simplify it. Now left hand side AE by EC is equal to AE dash by E dash. Now adding 1 on both the sides, add 1 on both the sides, it will become AE by EC plus 1 equals to AE dash by E dash C plus 1. Adding 1 on both the sides. The reason is adding 1 on both the sides. So adding 1 on both the sides. Now find the LCM, or the LCM will be here EC and it will be here numerator AE and here 1, so it will be here EC. Equals to, same here, find out the LCM here. E dash C plus 1 is LCM is E dash C, and here it is AE dash plus E dash. It's a simple simplification, finding the LCM. Now, or see the diagram, AE plus EC, what it gives? AE plus EC, AE plus EC, what does it give? The full line AC, the full side AC. AC upon EC equals to, now AE dash plus E dash C. Check here. AE dash plus E dash C. It also give a full side AC. AC upon here E dash C. Now this and this can be cancelled. Now cross multiply. EC 1 ja, EC is equal to E dash C 1 ja, E dash C. Now EC, this is bit contradictory. EC is equal to E dash C. EC is equal to E dash C. How it can be possible? It is not possible. It is not true. EC cannot be equal to E dash C until and unless this E dash and E coincide. That meaning, if they lies on the same point, in the same point, if E dash and E lies on the same point, then only this is possible. EC is equal to E dash C possible. So EC is equal to E dash C is contradictory here. So it is possible only if E dash and E coincides. So you can write, this is possible. This is possible only if E and E dash coincides. If this is possible, EC is equal to E dash C only if E and E dash coincides. And if E and E dash coincide, meaning we have already drawn according to construction DE is parallel to BC. Coincide means the point E and the point E dash is same, in the same point. So according to constructions, what we have written, according to constructions, our DE dash parallel to BC was drawn. Therefore, since these are equal and it is possible only, EC and E dash is equal, it is possible only if E and E dash coincide. Therefore, E dash and E are lie on the same point. So what you can write, DE dash, E dash and E must be in the same point. So in place of E dash you can write DE parallel to BC. And this is what we are about, that we are about to prove, that we proved. DE is parallel to BC is what we want to prove. So DE is equal to parallel to BC, which is proved. We can write hence. So this is the converse of basic proportionality theorem or Thales theorem. So thank you, and next lesson we will go to another theorem. Thanks.